So hello everyone, welcome back, and we are going to solve some Leetcode today. So the problem that we are going to discuss is evaluate reverse Polish notation. This is fairly simple problem and it is well articulated in words because it's an older problem from Leetcode, and that was a time when Leetcode was actually serious about, I mean, not Leetcode, I just don't blame Leetcode for that, but they were very serious articulating the solutions, and this is very bare bone and very basic as a problem. So it's not that hard and a lot of people are doing it. So let's go ahead and discuss problems. So the format of this video is always going to be as similar as we always used to do, like just talking about the problem, just reading the problem statements, looking for examples with the help of MS Paint, and then trying to write code which actually is fairly simple. So I hope you might be interested in this problem, because yeah, this is a stack based problem and this is very important because it is from the very basics of computer, which is the postfix and prefix expressions that you have studied in your computer science degree. Fine, so go ahead and we'll read out the problem. So you're given an array of string tokens that represent an arithmetic expression in reverse Polish notation. So that's pretty basic, and I'm going to explain you what reverse Polish notation really do mean, because I want to tell this to someone who haven't read about what this actually is and just stuck there. So so the thing is, your computer likes to process the arithmetic expressions in a certain way. Humans and computers do it very differently. They do not do it the same way as we humans do, because we are humans. We cannot process it, or our computer cannot process the way that like normal humans do. So this kind of expressions is converted into this type of expressions where all the numbers are written behind an expression, which is this plus sign here. So all the numbers are written behind it, not forward it, and this is how you write it. Now I'm completely going to explain you, and I'll show you how it has been done by MS Paint by drawing it out on the screen. And I'm very sorry because I'm just drawing on my mouse. So let's read some notes, like what should we note, what are the important things that we should follow before solving this expression. So valid operators are plus, minus, division, and slash. Okay, fine. Each operand may be an integer or another expression, which is quite normal. Like yeah, it's an arithmetic expression, so we have integers and other expressions, but we don't have floats. That is something which makes our problem more easier. I mean, we really don't care, but yeah, it has gotten fairly easy for us. Division between two integer always trunks to 0. So there are cases when it's 0.5 and which is considered 1, or 0.6 is which is considered 1 sometimes. So we want to consider it as 0. If it's 0, it's 0. And yeah, there will not be any division by 0. So obviously we don't want infinite values, and in this particular case they are not giving us, so that's a plus for us. The input represent valid arithmetic expressions in a reverse Polish notation. Yeah, obviously they have to give us. So there are no chances of errors, so it will always be a reverse Polish notation. All these notation that are in test cases are valid. So the answer and all intermediate calculation can be represented in 32 bits. So yeah, we all have 32 bit integers, so the size is not gonna exceed. So we just don't have to take care of it. Now let's move forth. For example, I'm going to solve this one particular example or this one particular example, and I'm not going to solve this because this is quite lengthy and the process is fairly simple. It is not that complicated, or like I'm just gonna solve this one because this while explaining is gonna take my whole page here. So I'll quickly write all these expressions, all this input expression here, and yeah, I'm going to explain you why and how you should solve this. So the thing is, we are going to solve this expression using stack, and the thing is, this is a stack. I know that's a pretty ugly stack, but I'm going to stack in all the elements here. So my pointer is at 2, so I have stacked 2. My pointer is at 1, so I've stacked to 1 here. And then as soon as I reach to this expression which says plus here, that means all these elements in the stack should be added together. That is what all it means. So we are going to, first of all, we are going to pop these two elements out of the stack and then put the addition of these two numbers, which is 3. So I'm going to enter 3 here, and then I'll move forward here. So my pointer is here. I'm going to add this element into the stack, and then I'm moving my pointer at this particular element, and when I see it's in multiplication, I'm going to multiply all these expressions which is in the stack, which will give us 9, and then I'm going to pop it, obviously, and just put in 9. And what we have to return is the array, or like the stack ka topmost element, which is 0. So this is how you solve it. Now in this particular expression, we can actually look like 4, 13 and 5 are going to get divided. So no, this is how it goes. So 4 is going to add here, right? So I'm going to add in 4, right? And then I'm going to see, look, I'll explain you it in this step. I mean, this is quite some new problem there. So it's 4, it's 13, it's 5, it's a division operator, it's an addition operator, right? Now this is my stack. I'm going to push in 4 here. I'm going to then my pointer is going to go to 13 here, and then my pointer is going to go to 5 here, right? And then as soon as I hit this, right? As soon as I hit this, I'm going to pop these two elements. It's always these two elements. I'm going to pop all these two elements out here, and then just perform an division operation here, which is 5 1s are 5. I mean 5 2s are 10. 5 2s are 10, and this is 3. And the 3 goes down. 5 6 are 30. Okay, fine. It's 2.6, which is considered as 2, right? Then we have 4 in our stack here, and then as soon as we move our pointer, I'm going to add in 13 first of all. 2. And then as soon as I move to plus here, plus operator, I'm going to just add these two. That's how we get 6 here. So the rules are pretty simple. Just pop 2 elements, perform operations, add in a stack, just push in. It's repetitive, right? So you know why I'm not explaining this particular problem, because that is gonna take a hell lot of it, and that is and it is not that complicated. It's all same. So now we are going to implement a problem. So let's get writing a code. Let's go ahead and write a code. So first of all, I'm going to make a stack here, right? Integer stack, and I'll expr. So it's an expression, right? Then I'm going to start a for loop here, which has string in it, and I'm going to give it as s here, and then tokens, and then I'm going to make a for loop here, and then I'm going to write a if condition where we check if the expressions are plus, divide, multiplication, or like minus, subtraction. So let's go ahead and do it. So check if s is equal to addition. Then what we have to do is we have to extract 2 elements. I'm going to store it in a here, which is expr expr dot push expr dot top. Okay, fine. First of all, we have to push all the expressions here. So if these conditions are not met, so we have to push it. So I'm going to make an else here, because that makes my thinking process very good. Like, I know I have pushed it, right? And and these are all strings, so I have to convert it. So s to I, which is string to integer function, in build function. So I'm going to write it here, so it converts it, right? And then I'll take the topmost element and store it in A, and then expr.pop, I'm going to pop it anyways, and then I'm going to do the same for B, and then what I'm going to do is expr dot push B plus A, because it is going to cause some problem in subtraction and division. So we want to make sure that it doesn't happen, right? Now I'm going to do the exact same for everyone. It is for subtraction, it is for division, it is for multiplication, and I'm going to add an else if, nested else if. Okay, I'm going to do this exact same for everything. So yeah, so it is going to be minus, it is going to be division, and it is going to be what's left now, it's multiplication. Fine, so these all are going to process it, push it in expr, pop it out, stuff like that, and then I'm going to return the topmost element of the expr. So return expr. So we can't just do this because it's stack. So you have to go and return the topmost element in the stack, right? Okay, fine. We have a compiler error here. Fine, I've messed it up quite a lot, so my spellings are, so it's an uppercase P, which is not right. I hope all my test cases are accepted. Okay, fine, we have some new, okay, fine, we have wrote this, we have this covered. Fine, I guess it's an extra curly bracket. Oh, yeah, fine. All my test cases are accepted. It's not the most optimized solution. Let's see what the what is the most optimized solution. Yeah. So there are people that are doing in 0 milliseconds, and they are doing the exact same. Wow. So using this for loop, right? So they are doing via index. Fine, fairly simple problem. Fine, let's go. I hope you like the video. If you like it, just make sure you like it. Subscribe to my channel would be appreciated. Till then, bye bye, see ya. That's a pretty long video.